Audiophiles and mere audio enthusiasts, you want the perfect listening room, but without the hassle, time and expense of acoustic treatment. Now you can do it with a tiny box that'll cost you a lot less and around only half an hour of setup. Tiny box. Let me unbox it. So what's the problem? You want better sound, as simple as that. And hopefully you've realised that the best way to get better sound is to upgrade your loudspeakers, which will make a lot more difference than upgrading anything else in your system, particularly your DAC. Upgrading your speakers is easy, if you can afford it. Buy them, get some good strong men or good strong women to lug them in, you wire them up and you're good to go. But even upgrading your speakers won't get you the whole way to audio nirvana if your listening room is untreated. You're listening to a whole heap of random mush. The answer, of course, is acoustic treatment, which is not the same as sound insulation, by the way, and I'd have to cover that as a separate topic. Acoustic treatment is all about making your audio sound good inside your already well-insulated room. The trouble is that acoustic treatment is expensive for a bespoke design and then the cost of construction and installation. Or you can buy a few panels from a website and hope for the best. But if you want to do it properly and get guaranteed good results, it will cost you. If you want to wing it, results may be variable and your room could indeed sound worse than before. Not that I'd rule out acoustic treatment if you can afford it. Getting the room right in the acoustics is absolutely the way to do it, if you can afford it. This would be a huge topic for more than one future video, so for now, I'm going to take it that we'll just leave things acoustically as they are. The alternative to proper acoustic treatment is, I'm sure you know already, is some kind of processing before the sound comes out of the speakers. As a reality check, I'll just say that this can't correct all of your room problems. Flutter echo between parallel hard plaster walls, for example. It doesn't happen until the sound gets out of the speakers and into the room. There's no way it can be corrected in advance before amplification, nor can any other time domain issue, such as resonances from standing waves. But if some problems can't be corrected and others not corrected completely, that is absolutely no reason to give up. I'm a great believer in improvement, that in many aspects of human life, small improvements can bring massive benefits. And some of your listening room problems can most definitely be improved with little effort and at very reasonably low cost. So, frequency response, your streaming source, CD player, DAC, amplifier, they're all flat within limits that you can't hear. Your loudspeakers are not, and your listening room is not. In fact, your speakers and your room are anything but flat. They're all over the place in terms of frequency on the x-axis and amplitude on the y. So if we can improve on this, we'll have made great strides towards better sound. One way you could do this is get yourself a graphic equalizer and tweak it until you like it. Indeed, this is the way things work, or used to work, in live sound. But the better way is to analyse your room, detect and measure its faults, then have EQ automatically correct them as far as is possible. So aside from time defects like echoes and resonances, your biggest problem is going to be the frequency response of your combined loudspeaker room system. And it is a system. Neither can be judged properly alone. What's coming out of your power amplifier is in all probability flat, beyond the limits of human hearing, and we will accept that. What reaches your ears will be anything but flat. Your speakers may be flat-ish, measured in an anechoic chamber with the microphone directly on axis, but they're spraying out definitely non-flat sound from the panels of the cabinet. And off-axis, well, it doesn't strike your ears directly, but it bounces around the room, and it's not flat. And then your room. Is it the perfect shape for good acoustics? Or at least an approximation, with non-parallel walls, non-parallel ceiling and floor? No, it isn't. It's a cuboid. Or worse still, a cube. Are the proportions of your cuboid, height, width and depth, in the golden ratio of 1 to 1.6 to 2.5? If not, some of the resonances between pairs of surfaces, or the harmonics of those resonances, are identical, and thus boosted more. OK, touching on acoustic theory here, and you'll need a PhD to understand it all. But the simple problem is that the frequency response of your system at your listening position is not flat. So let's correct it. Oh, by the way, are your speakers properly set up? It's always going to be better to correct something that's already optimized as well as it can be. Just a thought. What we have here, therefore, is the IK Multimedia ARC, or ARC Studio. As the name implies, it is intended for the recording studio, most likely the home studio where acoustic treatment is cheap, thin, and mostly inaccurate, like mine. As a concept, this has been popular in the past, with software to plug into the home recordist's digital audio workstation and lessen the monitoring problems while work is in progress. Then on final mixing and mastering, remove the plugin because it has already done its work. This is okay, but a bit fiddly. So what IK has done is to put all of this into a standalone box. You set it up using a computer, but you use it just by itself. Now this, I think, is where the magic happens for music lovers, hi-fi enthusiasts and audiophiles. Expecting them to listen via a computer running digital audio workstation software with a plug-in in the master bus, well, that's a no. But a standalone box that you can connect, set up and then totally forget, well, that's a yes. It's a yes, yes, yes. There are several buying options, but to keep things simple, I'll just talk about what I have, which is the ARC Studio processor, measurement microphone and ARC 4 software. This is the top-of-the-range version at a price I see today of just under $300 USD. I'd have to wonder whatever could you buy for that amount that could promise such an improvement to your listening. Other than, of course, replacing your severely worn-out stylus, vinyl lovers. But you will need some extras for the setup process. You'll need a computer, I'm guessing you have one, and you'll need an audio interface. Aha! This is a little out of hi-fi enthusiast territory. But to explain quickly, it's a DAC. But it has an analog to digital converter as well, an ADC, which doesn't roll off the tongue really quite. So it gets the audio into your computer as well as getting it out. Do you have to buy one? No, you can borrow one because you'll only need it once. Do you know any young people who are into creating music? They all have digital audio workstation software and an audio interface. Even a cheap audio interface will do, as long as it has a microphone input and power for the mic. While you're at it, you might as well get this young person to come round and help you set up. They're good with this sort of thing. The rest of the setup is that you'll connect the ARC Studio between the outputs of the audio interface and your power amp or powered speakers. When you're set up, you can give the audio interface back to this friendly young person and maybe repay them with a bit of worldly advice. After the setup process, you can use any analog source such as your DAC or your preamp. To get going, what you'll do, therefore, is set up the measurement microphone on a stand, or anything that will serve as a stand because it's only temporary. Connect the microphone to a microphone input of the audio interface with an XLR cable. Something else that you'll need. Download and run the ARC 4 software and follow the instructions. Hey, I'm going to do that, skipping the boring bits in my video. So this is what I like to call my studio. This is where I make my videos. I make my irritating unboxing music in another setup. You can see my workbench, my computer, my speakers, my mic, my lights and my mess. No, I tidied. It's usually worse than this. Now, the keen-eyed among you will notice that my speakers are on plastic crates. Yes, I do have proper stands, which are in my other system at the moment. I could say more, but I'm sure my commenters will do that for me. If you look closely, you'll see the measurement microphone, which is positioned directly above my sitting position at the level of my ears. This is measuring point number 1. Oh, I should say that I'm analysing my room for just me, because it only ever is just me in here. You can, though, analyse for a wider area, up to a whole home cinema. Let's get going. So here I am in analysis. Some say I should have gone years ago. I'm going to choose advanced mode because, come on, you're advanced too. It takes only 3 times as long as quick mode, so it's not too much of a burden. 21 measurement points, which means 21 mic positions. Don't worry, I'm going to edit out all of my fumblings with the mic stand and play just the tests. Each point alternates between the left and the right speaker. The audio you'll hear is the actual sound picked up by the measurement microphone. I've faked left and right for the video because with only one mic, it's going to be mono, isn't it? But with just a bit of audio trickery, it's more like it sounded to me in the room. OK, first we set playback level and mic preamp level. Nothing complicated there. You can repeat the beeps as many times as you need to make the adjustments. Next, we're into the actual analysis. In advanced mode, this is on 3 levels or layers. 6 inches below the ear level, and 6 inches above. Each layer requires 7 mic positions, which the software calls points, so we capture each point in turn. The screen tells you exactly what to do. I'll go through this quickly, editing out all of the mic positioning and repositioning, and you don't need to see it. While each capture takes place, I'm crouching on the floor so that I affect the acoustics as little as possible. You might wonder whether you should be sitting in the chair while you take the measurements. I can't find any specific instruction in the manual, and the graphic does show someone in the chair. However, the consensus, as far as I could find one, seems to be that no, you shouldn't be there. I'm guessing that if you were, then you'd affect the acoustics twice. Once when you do the analysis and again when you're actually listening. Anyway, here we go. All of the analysis, none of the messing around, some of me rustling in the background. I suspect you're getting the idea now. I'm going to skip to the last couple of measurement points in layer 3. If there's a clamour in the comments, I might post the whole thing, but although it's interesting to do, I suspect it may be boring to watch. OK, we're done. I can save my results now. I've called it Grey Room because my room is grey all around, including the ceiling and my t-shirt. I can choose an icon too to represent my setting. There's nothing that really looks like my Yamaha NS10M Studios, so I've chosen what seems to be the closest. 2 drivers, closed box. Let's look at the results of the analysis. I'll start with before correction, which is my room as it is. There's a slight difference between left and right, which I'd assume is due to a small asymmetry at the back of the room, and maybe the positions of the windows. Other than that, what leaps out is a huge resonance at around 140 to 150 Hz. Hey, we're cooking. The distance between the front and rear walls of my room is 2.5 meters. The resonance between them calculates at just under 70 Hz. So I think what we have here is the second harmonic of this resonance. I suspect that you're wanting one of these now, even just to see what kind of problems you've been suffering. Looking elsewhere, we're seeing a combination of the really rather not flat response of the speakers and conditions in the room. And of course, not much in the bass below 120 Hz. And a roll-off in the high frequencies above 5 kHz. Let's see the correction. I'm targeting a flat response, by the way. There's more you can do, but I think I should stick to what's simple for now. Here we have before in green and after in orange, just on the left for clarity. In the orange after plot, we can see the 70 Hz resonance that was previously suppressed due to the low frequency response of the speakers. The 140 Hz harmonic is tamed considerably, and then we can see multiples of 70 Hz, which are, of course, more harmonics. You'll notice that the correction doesn't go all the way to flat. In my music production exploits, I've played with plugins that attempt to match the frequency balance of a reference track. What I found is that if you dial up the correction to be as strong as possible, the results subjectively sound worse than if you give the processing a bit of slack. So this, I suspect, is what we have here. Movement towards flat, but not entirely the whole way, because that wouldn't sound as good. This is my speculation. Anyway, right up in the top end, we can see that the response has been brought up closer to flat. Taking all of this into account, we can expect the correction to improve accuracy across the mid-range and bring the bass and high frequencies up closer to where they should be. You want to hear it! Of course, there's no substitute for being in the room. But what I'm going to do is play you a track without correction, then with correction. Since the track is flat, or at least balanced in terms of frequency, to start with it'll sound correct before the correction. Then you'll hear what the correction does. OK, this is a bit backwards, but I want you to hear the amount of difference. That it isn't a small, hardly detectable difference, but clear and right in your face. If you do invest in room correction, then this is the kind of difference it will make. Here's the track before correction. And here it is after. Remember that this isn't what you'll hear yourself. It's just a guide to the magnitude of the correction, or at least the magnitude of my correction in my small room with rather less than flat speakers. What you'll hear in the uncorrected version is a good frequency balance as I originally judged it on headphones. In the corrected version, you'll hear what the Arc Studio had to do to correct my speakers and room. More bass, more high frequency, less mid but a flatter mid. You might want to listen again, but I'm going to press on. I'm going to stress what I see as the main point here. You do the analysis once, then you can free yourself from your computer and the analysis software. When you've done analysing, one click and you've transferred your measurements into the Arc Studio unit itself, which will do the correction. You can disconnect the USB and put your computer back in your home office or games room where it belongs. All you have to do is switch on the Arc Studio with the rest of your system and listen. Really, that's all. So is all this expense, time and trouble worth it? Come on, £300 or dollars, half an hour to set up, use it every day for a lifetime. OK, so multi-kilobuck acoustic design and treatment will get you better results, but I'd say that if you don't have any formal acoustic treatment at the moment, then the Arc Studio will get you along the way. You know, I've reviewed quite a lot of gear over the last couple of years. It's always interesting, but the plain fact is that there are really quite few items that I continue to use for listening, making music or making my videos. With the Arc Studio, however, I really do feel that not only am I getting closer to an accurate sound when I'm working with audio or just listening, I also feel that I'm enjoying what I'm hearing more. I hope that commenters who haven't yet tried room correction will weigh in with their hopes and maybe their doubts. And if you have tried it with whatever system, let us all know what improvements, or otherwise, it made. See you soon.
I think I followed most of that, Betty. But why can't room correction fix time-based problems like resonances?
Debbie, It's because a resonance means the sound keeps bouncing around the room, like an echo that lingers. EQ can't stop that, but if it reduces the volume at that frequency, there's less energy feeding the problem, so you don't notice it as much.
Thanks, Betty. I've got it now.